right? Example 6, a rectangular page is designed to contain 48 square inches of print. The margins on each side of the page are 1.5, on each side is 1.5 inches. At the top and the bottom, it's 1 inch. So that's what I'm showing here. Okay. What should the dimensions of the page be so that the minimum amount of paper is used? Okay. We know that the printed area, that's the area in the middle, is going to be 48 square inches. X times Y is 48 square inches, right? But the total paper that's being used is not just the printed area, it's also those margins that are added in, right? So how do I find the area? How could I write a formula for the area of the whole page? I mean, if I call it like this, right, this could be our length, and this could be our width, then we would say the area is the length times the width. Okay, but now let's substitute with expressions of X and Y. What is the length? It's X plus 1.5 plus 1.5. It's X plus 3. Right, so the area is, the L is X plus 3. What is the W? Y plus 2. Okay. Now, we need this area to be a function of one variable only, but that's why they've given us this thing right here. So let's make area a function of X. How would I do that? Solve for Y. Y equals 48 over X. And now we can put that in the place of Y there. So now we've got area as a function of X. X plus 3, 48 over X plus 2. Okay, so their question, now that we've got that, now you could simplify that, but it really doesn't make much difference at this point. They want to know what are the dimensions of the page so that the amount of paper used is the minimum, meaning that the area is a minimum, right? This total area is a minimum. They'll use the least amount of paper if they do that. Okay, so you graph it. And whether you graph it in this form or whether they did a little bit of simplifying but actually didn't do it all the way, it doesn't matter, right? Just put it in the calculator. And I hope that it's not like the last one that I get. No, I got it, and it's right away. Put it in the calculator just as it is. And then look at the graph. Now, if you notice the dimension, I took my dimensions, I set my window, basically looking at their graph. They've set the graph to be 0 to 24. So they're saying that the X could be no more than 24. And that's probably a good estimate. And the area is what sets the Y. And so they're going up to 120. We might have had to play around a little bit to figure out what our window should be, but eventually we needed to be able to look at the graph and see that there is a minimum on that graph. Okay, it's not something that we can do in any other way except look it in the calculator. Next year, when you're in calculus, you'll learn how to do this without a calculator. But this year, we have to use the calculator. So in order to find the minimum on a graph, first you got to see it on the graph, and then second, calc, minimum is number 3, right? You got to go to that left bound, right bound, right? Either use the cursor to scroll to either side, that would be a good left bound, right? Or just enter a value that you can see is on the other side. And if you're happy with this as your left bound and this as your right bound, and we are, then just let the calculator tell you that it's 8.48, about 8.5 inches is what the X is. So if I put it in here, if X equals 8.5, then Y is 48 divided by 8.5, which is 5.6. Now, if they want to know what the dimensions of the page are, you would have to say x plus 2, x plus 3 was the 1. That was 11.5. And the y would have been y plus 2, which is 7.6. Like I said, there's one homework problem that's pretty much the same, it's just different numbers.